Good morning, everyone. Welcome back to our study of pre-algebra. I'm Miss Betsy, and we are using as our text Pre-Algebra for Christian Schools. That's published by Bob Jones University Press. It's easy to follow along with me if you're using a different text. The topics are the same, so just search my videos according to what topic you're looking for, and you should be able to find something out there. Before we begin, can you tell me what is the only coat that you can put on when it's wet? Well, it's a coat of paint. This morning we are on page 46 in our text, and we're in section 2.3, which is called Properties of Multiplication. And it's important that we learn various properties that go along with algebra, because what the properties are, they're statements that have been proven to be true always. They're very consistent. God is consistent always. These properties that we use in algebra are consistent always. And we've studied and seen that, in addition, it doesn't matter what order you add two numbers together. That was called the commutative property of addition. They have a matching property in multiplication. That's the commutative property of multiplication. And that is, mathematicians love to say the words intuitively obvious. What is 4 times 3? Well, 4 times 3 is 12. You automatically learned from learning your times tables that 3 times 4 is also equal to 12. And that's what we're calling the commutative property of multiplication. And what that tells us is that the order in which two numbers are multiplied together has no effect on the answer, no effect on the product of this multiplication. This is called the commutative property of multiplication, and it says for all numbers A, B, and C, it says that A times B is the same as B times A. And this is the commutative, not commutative, but commutative property of multiplication. And the fact that you're allowed to change the order in which you multiply two factors together, the fact that that doesn't matter, has no impact on the result, is very important in helping us solve algebraic problems later on down our road. And you can use this commutative property, the fact that you can change the order, with what they call equivalent expressions. And remember that equivalent expressions and equal expressions do not necessarily mean the same thing. Two statements can be equal, they can be identical, without being equivalent. Equivalent just means they have the same value. So let's look right here. This is example number 1 on page 47. And what it says is, write an equivalent expression for 6x using the commutative property. So if we have 6x, and remember to be writing your x using a cursive type of x, so that there's no danger that you're going to be confusing it with an old multiplication symbol. So we learned that 6x is really saying 6 times x. So if they ask us to write an equivalent expression in your homework, you think, what in the world is an equivalent expression, and how do I use the commutative property to write one? All they're doing is saying, hey, remember when you're multiplying, it doesn't matter what order you multiply things. So an equivalent expression for 6 times x would be x times 6. Or it would look like x times 6. And at this point you're thinking, why in the world am I doing that? That's sort of silly. It's because they're teaching you, ingraining in your memory, in your mind, the fact that you can reverse the order in which you multiply two factors, or the order in which you add two, they call them add-ins, add two numbers or a number and a variable without changing the resulting value. And that's also something that you use. You don't just do it when you have two numbers that you're multiplying together. Let's say that we have 12 times 25. This would be read the quantity 12 times 25 times 3. Now, we've learned here, in addition, that if we have 2 plus 3 plus 5, 5 plus 5 is equal to 10. We followed a regular order of operations, worked from the inside out of parentheses, then addition in order from left to right. We also learned, however, that will get me out of the picture, but you can still see the board, that we can change the way in which we group our add-ins together. 2 plus 8. You see that regardless of which way we grouped this collection of numbers that we're adding together, you end up with the same result. Now if you look at what I've written here on the board, which would make more sense to you to group together first? Well, to me, 2 plus 3 is 5 because it's easy to count by 5s, 5, 10, 15, 20. Here it's 2 plus 8. I'd rather add two 5s together. Does it matter which two you group together? No, not in the least. And you can change this grouping when you're multiplying also. Let's say we have this problem. 12 times 25 times 3. What's 25 times 3? Always when I'm using 25s, 10s, 5s, I like to convert it into money because I might not think 3 times 25 is 75. Actually, I would, and so would you, but 3/4 is 75 cents. So here we have 12 times 75, and then you multiply out to the side. Do not use your calculators. 2 times 75 is 150. 75. Your solution, or the value of this expression, is 900. Now, using what I just said about quarters, is there a way that we can group this differently? Well, sure. We can say, let's multiply these first two numbers first. 12 times 25 times 3. How much money do you have if you have 12 quarters? 300 times 3, 3 times 300 is 900. You have the same result, both equally legitimate ways to arrive at that result, but to me, the second way is a lot easier. I didn't have to write the number off to the side. So this is what they call the associative property of multiplication. And that just says that when you are multiplying more than two numbers together, their order doesn't matter. Doesn't change the value. And this says for all whole numbers. What are whole numbers? Well, they're parts that don't have fractions with them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For all whole numbers, A, B, and C, A, let me see how they want to write this. A times the quantity, B times C, is the same as the quantity A times B times C. In other words, you can change the way that you group pairs of factors together in a multiplication problem, just as you can change the way that you group add-ins together in an addition problem. And both with addition and with multiplication, these two properties are called the associative property of multiplication, obviously with multiplication, the associative property of addition with this. So we have one more property that we want to mention again in this section, and this is another one that is obvious to us. If you have $100 and you multiply it times 1, you get a whole lot more, right? Well, no. Multiplying something by 1 doesn't change the value. You still have the same identity. You have the identical amount of money. If I have $100 in my pocket, and actually I think right now I'm not even sure I've got a penny. See if I even have a penny in my pocket. Nope. Let's pretend I've got a penny in my pocket. I multiply it by 1, I still have just a penny. I have the identical amount. So what they call the identity property of multiplication says this. For all whole numbers, if you have a number represented by the variable a, and you multiply that times 1, that's the same as saying 1 times a which is the same as saying a. Your identity property says when you multiply something by 1, you don't change its value. And you use this all the time in elementary school when they said, okay, rewrite this fraction here with a denominator of 6. What did you have to put in your little box here? Well, you had to put a 4. And the way that you did this as you moved on up a little bit in school was you said that 2/3 times 2 over 2 gave you 2 times 2 over 3 times 2, which gave you 4/6. So 2/3 was equivalent to 4/6, and the way that you did this was by multiplying by the expression 2 over 2. And you had learned that any number divided by itself is always equal to 1. And your identity property here of multiplication tells you, property, that when you multiply something by 1, that the value of it doesn't change. The appearance of it changes, and that's what we're using. Because we have lots of different ways that we can write 1. And it's when we use a different way of writing 1 to multiply something by, that helps us solve problems, and that's why this identity property of multiplication is so very important. And that's the end of section 2.3. Y'all have a great day.